Good day, people. Today we're going to solve inequalities using the addition and subtraction. Before we can solve inequalities, we need to know what inequalities are. So here are the inequality symbols. We have greater than, less than, greater than or equal to, because it has that little equal to on the greater than as well, and we have less than or equal to. So it has a less than sign with the equal to on it as well. How do you know the difference between greater than or less than? Just think about the number line. So if you notice, the greater than is pointing to the right of the number line, while the less than is pointing to the left of the number line. And when we go to the right of the number line, we are increasing. When you go to the left of the number line, we are decreasing. So you can bear that in mind. There are a few words that we must know, and we must know what inequalities represent them to be successful in this topic. We have cannot exceed. If I tell you cannot exceed a certain amount, that must be less than or equal to for the inequality that would represent that one, because it cannot exceed it. So you can only go up to that point and lower. At most, if I tell you the at most, you know that I'm talking about it's the most you can actually go to. So that would be less than or equal to as well. If I tell you that most, all right. If we have at least, if I tell you that you're doing a test and you have to get at least 65 to pass, that means you have to get 65 or greater. So at least would be greater than or equal to. Greater than, we know it's this symbol already, and less than, we know it's that symbol. So those are some few keywords that you need to know. All right. On the airline that Raul is using, the weight limit for both suitcases combined is 50 pounds. How much can Raul's second bag weigh without going over the limit? So we know the weight limit is 50, so that means we can have 50 or less. So we see that the inequality that we would use is less than or equal to 50, because we can have 50 pounds or less. All right, we can let X represent the weight of the suitcase that we don't know. So we can let X represent the weight of the second suitcase. Okay, since we know the weight of the second suitcase, we know that the weight of the first suitcase is 38. We know their combined weight should be less than 50, so we know that we are adding. Their combined weight should be less than or equal to 50. All right, so we're going to solve this inequality now. How do I get X by itself? I have to eliminate this constant. If you notice, we're adding right here, so we have to do the opposite of adding. We have to subtract. So we're going to subtract 38 from each side of the inequality. So we have a 0 pair right here. We see that X would less than or equal to 12. What does that mean? It doesn't mean X equals 12 only. It means X can be 12 or any value less than 12. So on our number line, this is what it would look like. All right, we can put 12 there. We can put in a few more numbers: 10, 8, 6, 4. All right, so how would this look on our number line? So we draw a circle at 12. Since it's equal to 12 as well, it can be equal to 12. We have to shade the circle. And then our arrow will be going to the left to show that it's less than 12. So it's equal to 12 or less. So that would be our answer. So our answer could be 12, 11, 10, 9, 8, 7, 6, 12, and any value less than 12. Okay, let us try another question. The weather forecast predicted that the evening temperature could get as low as minus 12.5 degrees Fahrenheit. So if it can get as low as minus 12.5 degrees Fahrenheit, you're supposed to start thinking about the inequality that would use to represent that. Between the afternoon and the evening, the temperature dropped by 7.5 degrees, and the forecast was still correct. What could the afternoon temperature T have been? All right, so we know the afternoon temperature is T. We know that it dropped by 7.5, so we can put subtract 7.5 to show that it's a drop of 7.5. And they said it went as low as, so that's as low, so it as low as 12.5 degrees, which means it could be higher than 12.5 degrees. So we have to use greater than or equal to negative 12.5 degrees. From there, we could try to eliminate the constant again, trying to get the variable by itself. So we can do the inverse operation. So we notice that we are subtracting 7.5 here. So we could add 7.5 to this side of inequality. We have to add it to this side as well to keep the equation balanced, or the inequality balanced, sorry, because it's similar to an equation, but it's not an equation. All right, so we notice that we got a zero pair here, right here. We see that t will be greater than or equal to 5 degrees. Sorry, negative 5 degrees. So the afternoon temperature would have to be negative 5 degrees or greater for it to meet this condition. How would it look on the number line? So we draw our number line. We have 0, negative 1, negative 2, negative 3, negative 4, negative 5. So we put the circle at negative 5, and you notice it's equal to, so we have to shade that circle. And since it's greater than, we'll go to the right. So that's what our number line would look like. And remember, the values of t can be negative 5 or any value greater to satisfy this condition. Thank you for watching. Goodbye.